I'm Jerry Tyson of Arnold Matus & Associates. Today I want to talk to you about Parker's family of ACR controllers, specifically the ACR motion profilers. Now, this family of controllers is a very powerful motion architecture. However, it can be confusing to people the first time they see it. Complexity and flexibility are often two sides of the same coin. In this video, I hope to demystify the complexity and show you the flexibility of Parker ACR controllers. So to start off with, you may ask, what is a motion profiler? A motion profiler generates the mathematical representation of a commanded move. The acceleration, velocity, deceleration, and position described by the associated commands are all computed to produce a motion profile. Each motion profiler provides a different method for commanding motion. The output of these profilers can be combined to create very complex motion that's easy to program. The ACR controllers have four types of motion profilers. The first is the Coordinated Moves Profiler. This profiler allows for the multi-axis linear and circular interpolation moves along the paths that can be described with commands like MOV for linear interpolation, CIR-CW and CIR-CCW for circular interpolation. SINE provides a sinusoidal path, and TARC creates an arc in 3D space. Next, we have the Jog Profiler. This profiler allows for axis-independent, also known as single-axis moves, that can include continuous, absolute, and incremental positioning. Next is the Gear Profiler. This profiler uses the gear command to make moves based on an external source. It electronically mimics a gear and allows for on-the-fly changes to the gear ratio and control of the acceleration and deceleration ramps. Lastly, we have the Cam Profiler. This profiler uses the Cam commands to create complex motion described in data tables. It matches the position of an axis to the position of an external source by doing a lookup and interpolation function to achieve the type of motion that historically required a machine cam and a follower. One of the first things that confuses some people is that the controller requires you to set up a master axis no matter what type of motion you will be commanding. The Parker Motion Manager, or PMM software, includes a configuration widget that makes this simple to set up. With the multi-axis controllers, you need to attach all of the axes that will need to be coordinated to the same master axis. And the IPA, which is a single-axis drive controller, can also use the MOV and other coordinated motion profiler commands, even though it is not coordinating with other axes. The important point to remember is that each of these profilers is creating a different coordinate system. These coordinate systems can be combined and shifted in very powerful ways. Let's look at a Servo status panel in the Parker Motion Manager software to show the relationship between these coordinate systems. In the first portion of the status panel, you'll see the four motion profile registers are combined to create the primary set point. The primary set point is then summed with optional ball screw mapping and a backlash offset to create the secondary set point, which is the commanded position. And you can see here that when you subtract the actual position from it, you get the following error. The summation of profilers allows you to easily do a phase, advance, or retard on top of a gear or a cam move. It also allows you to duplicate moves over an area without having to recalculate new positions every time. We'll do an example of this later on. However, if you're switching back and forth between the profilers, you must be aware they are separate coordinate systems. Let's take a look at some examples for clarification. First, we'll use the RAS command to reset the actual position in all the profilers to 0. RAS X. 0 is implied. Then we'll use the MOV command to move from 0 to 90. That's MOV X90. Then we'll do the Jog ABS X90. You think it'll move? We'll find out. Then we'll do some gearing and have the axis follow for 90 degrees. As you can see from the diagram, each register contributes 90 degrees and thereby commanding the actual position to 270. This will probably make more sense if we watch the motor in the data live. First, let's do the RAS command to change the actual position and reset all the registers. Then we'll enable the drive with the drive on X command. Let's go ahead and turn on the gearing with the gear on X command. I've already set up the ratio 1:1 between the master and the follower. The MOV X90 command, as you can see, makes it turn 90 degrees. The Jog ABS X90 turns an additional 90 degrees. And then when we move the master, the slave follows for 90 degrees. Now how would you move back to the 0 position that you started from? Can you just make a move with MOV X0? No. This would only move back to the 0 position in the coordinated motion profiler coordinate system. You're still 180 degrees away from the original moves due to the jog profiler and the gear profiler. You can use the jog res and the gear res commands to reset the offsets and move their values to the coordinated motion profiler coordinate system so that you can then move to 0. Jog Res X, Gear Res X, Move X0 would take you back to the original point. So type in MOV X0, and you'll see that it only goes back 90 degrees because that is the 0 point of the coordinated motion profiler. We can then use the Jog Res X command to move the jog offset to the coordinated motion profiler, and the Gear Res X command to move the gear offset to the coordinated motion profiler. Then we can do a move X0 to move back to the original position. Another command that's used to manipulate some of the motion profiler registers is the Ren command. The Ren command can be used to reset the coordinated motion profiler to a value of the encoder. The Jog Ren command, on the other hand, allows you to move the value of the coordinated motion profiler to the jog profiler, which is basically the reverse of the Jog Res command. Okay, let's see the Ren command in action. First, let's turn off the gear. Then we can disable the drive. Now let me move the axis by hand. Let's go roughly negative 81 degrees. And you can see the actual position has changed. If I use the Ren X command, I can then move that value to the current position of the coordinated motion profiler. Okay, now let's look at an example of how this architecture can make programming so much simpler. Your goal is to program the moves to laser cut these diamond shapes from this square piece of material. The process is simplified by using the jog profiler coordinate system to offset each of the starting points and using the coordinated motion profiler for the linear interpolation moves. As you see from the diagram, this makes the moves for each diamond identical and therefore can be put into a Go subroutine. Then it's just a matter of using the jog commands to move to the starting points of the diamonds in a coordinate system that is referenced to the dimensions of the sheet of material. You can use nested loops to calculate the offset for the rows and the columns to make the program even more compact. You could also calculate the number of diamonds that is possible to cut in a sheet of material given its dimensions. Hopefully this gives you some insight on how the power of Parker's ACR family of controllers can make your motion programming a lot easier. Please like and subscribe so you can stay up to date on the latest motion products from Parker.